Okay, so here we are. We're going to talk about specific neurotransmitters. I've chosen these examples because I think that some of them demonstrate excitatory and inhibitory really nicely. Some of them demonstrate how we can interfere with neurotransmitter, uh, well, how we can interfere with neuron communication through neurotransmitters and how we interrupt them. And then some of them are just particularly important to talking about psychological functioning. So let's start by talking about noradrenaline. And you can see that the word adrenaline is part of this. Nor just refers to neurology or the brain. So this is a version of adrenaline that is used in our brain. And I'm betting most of you are familiar with adrenaline and the idea of an adrenaline rush. And what you understand about adrenaline probably is that it makes lots of things happen. It's, kind of speeds or enhances performance in some way. And that is a good way of understanding what noradrenaline does as well. And so this is a nice example of an excitatory neurotransmitter because probably your understanding of adrenaline tells you pretty clearly that this is going to be excitatory. It's going to make things happen as opposed to quieting things. And it's going to activate your central nervous system and make you pay more attention to things and make it more likely that you're going to act in some way. All right, so noradrenaline is great for telling us exactly what an excitatory neurotransmitter is. But acetylcholine is a little bit more complicated. And you can always write this out as ACH. You don't need to remember how to spell acetylcholine. But it is excitatory for some functions and inhibitory for other functions, which is why it's a little bit more complicated. And so ACH is used in our voluntary muscle system. So voluntary muscle are my skeletal muscles, moving my arms, right, moving my mouth, moving my tongue, things I move on purpose. It's excitatory there. So acetylcholine is used in those systems to tell muscle to move and to send messages to the muscle to get it to move. So using, even the neurons that lead up to the muscle will use acetylcholine in that way. But it's inhibitory on our involuntary system. And so essentially our heart, right, that's not voluntary. You're not making your heart beat on purpose all of the time. And so ACH is one of the things that might help your heart to pause in those helpful ways between beats. It's also excitatory on learning and memory. And in fact, acetylcholine is an important neurotransmitter in understanding what happens when people have Alzheimer's or other forms of dementia, that often ACH is not working as well in those areas of their brain as the disease advances, and therefore their ability to remember and to learn new things is impaired because of the relative absence of ACH. And ACH is also gives us some examples of how we can disrupt neurotransmitter use. Curare, and when you look at the static slides, you can go to the Wikipedia page that explains curare a little bit more. But it is a poison. It's made from poison dart frogs, and some of you may remember those colorful frogs you might have been fascinated with as a child. I know my kids had little rubber plastic versions of them, and they were blue and spotted. But poison dart frogs are used to get curare, and it paralyzes people by preventing ACH from entering the receptor site. And so curare sits in the receptor site, kind of like gum in a lock, and the ACH can't get in. And if the ACH can't get in, then that neuron just sits there not knowing anyone's trying to send it a message, and then it doesn't send those excitatory messages to muscle, and so we don't move, right? Paralysis. Another thing that can disrupt acetylcholine is something called botulism. Botulism is a mold spore. And as healthy adults, botulism won't bother us much. You find some botulism in honey, because honey, if it's not pasteurized, might have that in it. You might have grandmothers who told you never to eat food from a dented can. Dented cans are actually fine. It's cans that are bulging that are problematic because there's gases being produced by the mold spores in there that are making it bulge. And it happens mostly with home canned things, not with things we buy in the store and that have been heat pasteurized to a great extent. So botulism can cause paralysis and death, but it works differently than curare. it prevents ACH from being released from the terminal knob. And so the neuron gets a message, it goes through the whole electrical spiel, and then when that process reaches the terminal button, ACH prevents the button from releasing the ACH into the botulism prevents the terminal button from releasing ACH into the synapse, and so the next neuron never gets the message, and that never happens. Nothing happens. It also so paralysis is about the interruption of the excitatory messages, but then heart failure happens because we can't stop the heart from beating wildly with those inhibitory messages that should be happening and can't because ACH isn't available. And interestingly, for those of you that didn't know, Botox is simply a form of something derived from botulism. It's made from botulism. And so you can take a look at that link from the static slides if you'd like to learn a little bit more about that. But if you think about what Botox does, you inject Botox around your mouth, right, because you don't want to have wrinkles. You're not really getting rid of the wrinkles. What you're doing is you're paralyzing little teeny bits of muscle by putting the Botox in that is really botulism, that is really interrupting ACH. And if I can't move all those little muscles, then I can't wrinkle my skin. That is really what's happening. Some of you may also know that Botox is used to treat migraines. Migraines occur when muscles contract around blood vessels and then release, and it causes the migraine. I'm sorry. Hang on a sec. Sorry about that. Dakota knocked over a little table here on the screen porch. And also for chronic back pain that's caused by muscles contracting, we might use Botox to stop those contractions as well. All right, so let's talk a little bit about dopamine. Dopamine also has several jobs. It's just as ACH was excitatory involuntary muscle, dopamine is inhibitory involuntary muscle. And so one of the things to imagine is that dopamine and ACH are often in the same synapses and landing on the same neurons, one of which, right, dopamine is sending inhibitory messages, telling that neuron, whatever you do, don't fire, while ACH is sending excitatory messages to tell it to fire, and then seeing whether it meets the threshold for firing. And so it allows you to keep your body from moving, right? So again, dopamine is the thing that lets me hold my hand still. If I had Parkinson's disease, and some of you may know people with Parkinson's, the main symptom that we often see is tremoring, movement disorders, right? So Parkinson's is a movement disorder. We see tremoring, and the tremoring is happening because of a failure of dopamine, that not enough dopamine is being produced, and the person with Parkinson's disease gradually loses their ability to hold their body still in all kinds of ways. Dopamine, however, is also excitatory. It's excitatory in our emotional system and our reward system, and dopamine is really important in motivating behavior. That it gives us a reward when we do things, and that makes it more likely we will do things the next time we have the opportunity. Almost anything you enjoy doing probably gives you a little dose of dopamine during it, and that's why you say you enjoy doing it. So it's an excitatory neurotransmitter in our reward system as well. Serotonin is a really important neurotransmitter from a psychological point of view. Sorry. And I bet most of you have heard of serotonin somewhere along the way. As I hinted at earlier, we can talk about a little bit more now. Antidepressants that most people are really familiar with, either from television commercials or by knowing somebody who's been on them or being on them yourself. Prozac, Zoloft, Lexapro, Paxil, the whole host of them that are selective serotonin reuptake inhibitors. And what that means is that, right, if you remember what reuptake is, that these medications stop that reuptake process, and therefore they leave more serotonin in the synapse, so that you have more serotonin to use at any given moment. Lots of people mistakenly think that serotonin is excitatory because it helps with depression, it helps solve depression. They think it must be excitatory, but really it's inhibitory, and it's inhibitory in a way that it stops you from responding in negative ways. It's a regulating neurotransmitter, and so it helps depression and anxiety by helping to regulate mood and sleep and also appetite. It's very involved in digestion as well. Um, and I tend to think of serotonin, I like to think of serotonin as a resilience neurotransmitter, that it helps us not over-respond to things and that it helps us be resilient in the face of stressors or challenges. And I think, in fact, the antidepressants, that is one of the main things that those SSRIs do for us. They help us to be more resilient to life in various ways. Another neurotransmitter that's really important in terms of psychological functioning is something called GABA. And GABA is an inhibitory neurotransmitter in the brain. When we don't have enough GABA, we feel anxious, we feel scared, we feel worried. And things like Xanax, which we take often in response to those problems. Xanax and similar medications increase GABA, but alcohol also increases GABA. And I always want to take just a moment here to tell what is my GABA story. I think of it as my GABA story. Probably about, I bet it's about 12 or 13 years ago now, we went on what was for us was a big vacation. And we took the kids to Greece for 10 days. And when we were on the plane over the Atlantic on our way to Athens, there was a passenger on the plane who got very, very agitated, and he was a bit out of control. So he was yelling. He threw a glass of wine across the plane. He ripped a crucifix from his neck and threw that across the plane. And he was speaking Greek. And unfortunately, none of the staff on the plane spoke Greek. And so no one knew what he was saying. None of the staff on the plane knew what he was saying. And he was getting more and more agitated. And my husband, who at the time was doing medication research, could hear that what he was saying over and over, part of what he was saying over and over, was the generic name of a psychiatric medication. And Jim eventually got up and told the flight attendant that he appeared to be asking for the psychiatric medication. And what wound up happening through lots of consultation is that the pilot came on and said, "Ladies and gentlemen, we have a problem at on the plane, and we're wondering if anybody could help us out. Wondering if any of you have any medications like Xanax or Valium on you, whether you could press your call button." And the entire plane lit up. Like everyone except me on this plane had Xanax, apparently. And so what they did was they collected Xanax. They came up with a dose that would be enough to put him to sleep and not enough to hurt him. And they put him to sleep for the rest of the flight to Greece. But you have to ask yourself, why did so many people on this plane have Xanax? And the real answer is lots of people get anxious flying. And whether they got it from their doctor or their friend or wherever they got it from, many people on that plane had Xanax to help them cope with the worry. Essentially, they had Xanax to increase their GABA levels while they were on the plane. And so that is my GABA story, and hopefully that'll help you remember what GABA is. Glutamate is an excitatory neurotransmitter. It is kind of the opposite of GABA. Really important in memory, learning, and attention. And you may not be surprised, therefore, to hear that glutamate is the major thing that is affected by attention deficit medications, right? Attention deficit is a struggle with holding attention on things. Glutamate helps us do that by activating those parts of our brain. And so glutamate, those medications increase glutamate, and then we have an easier time learning, an easier time paying attention. All right, so we're going to pause there before we go to the next video.